When it comes to navigation, a building with smooth floors and straight halls is relatively easygoing. But robots will also need to venture out in the world and encounter terrain they've never seen before. Once again, how do you teach a machine to deal with the unknown? Part of the answer may lie here at Florida State University in Tallahassee, home base to innovator Dr. Emmanuel Collins. Working with a dedicated team of graduate students, Dr. Collins' mission is to help develop artificial intelligence that will allow robots to go anywhere, anytime.
Robots are primarily used in structured environments. What we're looking to do is develop robots that can traverse difficult terrains safely and efficiently.
The team took a standard off-the-shelf robot, then souped it up with extra processing power and mobility control. Then they developed the motion planning software and new mathematical algorithms that would allow it to adjust to the landscape it encounters. The first challenge, learning to climb hills, simulated in the lab by a wooden ramp.
To climb a steep hill, you need to use momentum. If you tell the robot to go too slowly up a steep hill, what you'll find is that it can't traverse the hill.
The robot fails on its first try, but instead of giving up or waiting for new instructions, it backs up for another go.
It kind of thinks, well, what does it take? What kind of momentum do I need to make it up the hill? Well, if that doesn't work, let me try this speed. Can I make it? If that doesn't work, let me try another speed. And so it develops that momentum, even if it requires it to back up, and then it will have basically the velocity to traverse the hill.
Another robot, under the guidance of PhD candidate Camilo Ordóñez, is designed to look for paths or ruts in the ground outside, then follow them.
Now the robot is all hooked up. We're ready to start running the code. It will start by mapping the terrain, and then it will try to track the ruts.
Like a smart driver, the robot surveys the road ahead. Its mapping complete, the robot begins its journey. It not only finds the ruts, but steers to follow them as they curve.
Who is going to use robots in outdoor environments? Well, primarily people who are interested in using robots for search and rescue, or for agricultural applications, possibly even space applications. In those environments, the terrains are going to be highly unstructured, so you don't know what you're going to encounter. We see, probably in the not too distant future, a robot that really knows how to move on a variety of terrains and will be highly reliable on those terrains.